was India ever ready for indigenization and in avionics at that point?
The idea was that let's try something that's tough.
The rising power of the graph of Bharat today. Technology, business acumen, marketing, I think a wonderful combination. I think really welcome. I think we in Bharat should be really happy for people like you, with people like you. What is the speciality about Zippo? How do you integrate these different aspects, different software for different products, which go into the microchip systems? How do you do that? Is it something very special for you, or is it commonly done?
See, now, for example, I personally have about one international patent and 2 Indian patents on a system which is called disseminated parallel control computing for real-time systems. It's a very complex term. But actually, see, what happened was that I can tell you the origin of this. It will eventually come to answer your question, but you might like the origin story. See, when we were making autopilots in 2014, see, an autopilot is something which a drone cannot fly without. It's like a motherboard, like a PC or a laptop cannot function without a motherboard. Similarly, drone cannot function without an autopilot or a basic flight control system. See, if you see, a FCS is a very, very complex thing when it comes to flying, because the moment you add the third dimension, that object has mobility in any direction. So even a RPM difference of say a few tens of an RPM difference between 2 motors can cause instability if left unchecked. So the flight control system literally does something which is managing chaos. Chaos is the randomness of the motors, winding, air resistance, all that put together. The flight control system's job is to make sure this doesn't go, it doesn't become random. Manage entropy is what we call it. So we were trying to understand what is the best way in which we could, create a control system. We were trying, different things like your smartphones, multi-threading, multiple apps, and we realized, that used to crash after some times, because in defense they have MTBF, mean time between failure, has to be in excess of 1,000 hours. So that means system has to work robust, it has to work at high speed, and it has to be, secure. So we said, we were trying to find a solution. It didn't, we tried regular approaches. It just happened that one day I was going from home to my house to the office. I was driving my bike. That time I had a bike. So suddenly there was some cow which cut in front of the road. It normally happens in Indian roads. I swerved the bike. But it so happened that day that I observed my brain at that point. So like, what is our human control system doing? How is it able to do it so well? See, we are able to drive a bike, we are able to fly a plane. And we are able to do both efficiently and scalably. So we said, okay, we should look at this. Maybe this could be a method of our control system. So we realized that, as humans, while controlling anything, we have a reflex action, which is immediate, spontaneous, immediately avoid the object or, make sure the system is stable. And you have thought out process. They work simultaneously. You can try it next time, if you're going down the road, something cuts, you will swerve your bike, but if you observe your brain at that time, you're still thinking of tasks like, where do I go forward, take a left turn, there might be too much traffic there, it might be better to take this road, while you're avoiding this object at an instant. It's a beautiful system. So we realized we had reflect process and a thought out process. What did we do? We made an electronic version of this and called it disseminated parallel control computing for real-time environments.
And you have a patent on that.
It's commercialized?
Yes, it is commercialized. We have created 60 plus products with this technology. And we have, as of today, close to 430 deployments of our autopilots. And out of that, 150 plus are on the Ajit Scout drone with the defense. As a company, we have taken it from a paper up to a product. So to answer your question in terms of our basic method of our products and all these things are created with special softwares. The depth to which, like for example, it takes about 18 months for us to train a regular embedded engineer who works, say, in Bosch or one of the good reputed MNCs to start working on these mission critical applications. So yeah, manpower is there. There are challenges there also.